Good morning and good afternoon. This is Monica Paolini from Senza Fili, and today I'm talking to David FitzGerald, is the director at the Office of the CTO at Ascom. And our conversation today is for a report that Senza Fili has written in collaboration with RCR Wireless on RAN optimization and how it is changing with the increased usage and increased expectations about the quality of experience from subscribers. David, thanks for being with us today.
My pleasure.
So to get started, can you tell us what you do at Ascom in terms of optimizing the RAN?
Sure. Well, Ascom's been in business almost 25 years. We do business all over the world with almost all the network operators, all the vendors. And what we do regarding optimizing the RAN has always been from the point of view of the customer, of the subscriber. So, you know, we started in business 25 years ago, drive testing and in trying to put engineers as proxy subscribers to be able to optimize the network based on what subscriber experience is. So we've been in this business a long time. As things have changed, right, we've mutated and we have become more of an enterprise operation with analytics and core network testing and the ability to really bring powerful, almost real-time data into the operation of the optimization of the RAN.
Now, you've been in the business for a very long time, so maybe can you tell us how it has changed and what do we need to optimize RAN in a different way now that we did, say, 10 years ago?
Well, back in the day of GSM, before the advent of CDMA and WCDMA, you had capacity as a concept of a fixed number of users in a given 200 kilohertz channel. With the advent of CDMA and WCDMA, and now, of course, LTE or the other OFDMA technologies, you've got this concept of a shared channel, and you're mitigating interference through the use of codes. That means that there's this concept of soft capacity that has been introduced into the radio access network, which is a boon in the sense that you take advantage of good radio environments, you get much more capacity than you used to with a fixed allocation of frequency per user. Now you have this ability to have a shifting capacity based on the number of users, the near-far phenomenon, the radio environment, you know, the trees and the buildings around it. That can be a boon or it can be a drag, because if the radio environment is not a good one, then you're going to have less capacity than you do in a good radio environment. Now, the radio environment changes everywhere. Every sector, every cell carrier that's on a given sector has its own dynamic radio environment that changes throughout the day, given the traffic mix and the changing environment. So what has changed is that back in the day when we were able to understand what capacity was on more of an average or a fixed basis, now that concept has no validity. You have capacity changing dynamically during the day. You have it certainly changing over a period of time or year to year. And of course, as traffic increases, your challenge is, well, if my traffic is increasing, how do I really know what my capacity is? And when do I need to invest to maintain customer experience? So those are some things that have really changed. And it's only been made more complicated with the advent of LTE.
Mm-hmm. And this is interesting because what the soft capacity concept means is that you need to really act in real time. It's not, you know, it's still, KPIs are still valuable in terms of analyzing this, look at the historical performance, but you need to do more than that. You need to move beyond historical analysis and you need to be in real time. Can you tell us about what are the challenges of working in real time to optimize the RAN?
It's a great question, and of course, real time depends on the position of the user of the term. Real time can mean instantaneous in some applications, in some use cases, and real time can be more broad, like every 15 minutes or certainly on an hourly basis. In this case, what I'm talking to you about is the ability from the KPIs that are captured by the switch, by the OSS, for the ability of network engineers to get information that they can use to their advantage in 15-minute chunks, certainly on every hour basis, and understand how the radio environment has changed, how their capacity on a given cell sector has changed in a given hour, and how those hourly changes change from day to day. So soft capacity changes dynamically. The ability of big analytics and what we're doing brings you closer to being able to understand in real time, as we would think about it, in much more discrete chunks of even every hour, and be able to focus on that. Some applications and some use cases, real time is on a daily basis, but it's no longer something that we can address based on last week's or last year's data. Things are changing too fast for that.
Yes, and they're changing, in real time, depending on the usage as well. So it's not just the environment. So subscribers impact the performance depending on what applications they're using as well. Is that right?
It's a big Rubik's Cube, right? You've got, let's say you're a discrete cell carrier in a sector on a macro site somewhere, and whether it's urban or suburban, just take that as your use case. In the morning, it has much different traffic than it has in the afternoon or during the day, and forget about the weekends. You've got your near-far usage, people coming into the cell and moving out of it. You've got different applications being used, almost changing as the user cares. They're speaking in voice and using video at the same time, and then switching off to something else and web surfing. All those things change, and all those things affect the carry capacity of that cell carrier. Not to mention the fact that the radio environment's also changing on its own. And you combine all those things and you realize you've got a real challenge in understanding, given all the information you have and given your understanding of that radio environment, what is my capacity this hour? And how has it served my customers based on customer experience targets, not based on engineering network element threshold targets. And that's a big kind of a radical change in concept.
And this is really changes the perspective in which operators evaluate their own performance, because what you really care ultimately is the quality of experience from a subscriber point of view. And capacity is a proxy to that, but there is more than just, it's not just a very simple linear correlation, whether capacity or KPIs that are being traditionally collected. So how do you relate QoE to all that information that you have?
It's a great question. So let's say as an operator, you understand and you think that the best way to run your operation is based on customer experience metrics that you would want your subscribers to receive, that you would want to receive as a subscriber. And the challenge is, okay, knowing, well, what are the metrics that are being delivered? What am I delivered today? And how is it different from during the busy hour and the non-busy hour? And how is it different from when different applications are used? And what we do is we act like a scheduler. We pretend we're the radio resource manager. We've created a very interesting ability to act like a radio resource manager, understand what all the inputs from the network are, understand what the traffic is, understand what the radio environment is, understand what the user experience KPIs are, because the operators will pick that and they'll say, this is what I want to deliver. I want to deliver no more than 2% blocking on voice. I want to deliver no more than 5% blocking on a data session. I want to deliver 1, 2, or 3 megabits per second on the downlink for instantaneous throughput, depending on whether I'm in WCDMA or LTE. And I want to deliver this kind of instantaneous throughput on the uplink. We take all that information, we analyze it, and then we determine whether, in fact, that traffic using those applications at that time of day, at that place, was meeting your customer experience objectives or wasn't. If it was meeting it, we then understand how much in the future am I going to be able to continue delivering that based on your traffic growth forecast. If it's not meeting it, we tell you why it's not meeting it, what in the network has to change to be able to get you back to delivering those target customer KPIs.
Mhm. So here there are two different dimensions that you can help operators with. So in the real time, they can take corrective action based on the assets they have to improve QoE. But then there is still value in terms of the long-term measures that you're looking at in terms of predicting in the longer term. And that's not a real time. It's still sort of more closer to the old school, analysis of the KPIs, but it's done in a different way because you look at it from the point of view of QoE and what the targets are for operators. So it's not
Yeah, that's well
a little bit
said.
more complex than what
You've got two real use cases, right? You've got the use case of where we can deliver dynamic, almost real-time information, as you pointed out, to the engineer to be able to optimize his network today with the assets he or she has today. So I've got a configured site. I know what my licensing is arrangement with my vendor. I know what the radio environment is. I know what my traffic is. Given that, what can I tweak? How can I rebalance based on customer experience instead of just payload? How can I take advantage of the fact that I've got soft capacity in this good radio environment? Or how do I have to guard against the fact that I don't have good capacity in this bad radio environment? That's the one use case, right? Then the second use case, as you pointed out, is, okay, understanding the baseline and understanding where we are today with the traffic and the mix that we have with our current network. How do you forecast that configured, the current configuration is going to provide service off in the future? And what we take is we take the operator's forecasted growth, or we can just trend line it based on actual traffic growth, or a combination of those things. And we say, given what your constraints are, and given what your traffic is, and given on how it's going to grow, we can predict accurately that you're going to have enough capacity at this particular cell carrier for X amount of time. And that way you can start planning your investments in a just-in-time manner. Instead of spending money too early, you can spend it just on time. Just on time being within 1 or 2 months of when that customer experience target is no longer being met. Whereas before, you might have spent money 6, 7, 8, 9 months before that, before you even reached those limits, or you may have spent it too late. Those limits had already been breached, and now you were churning customers. Exactly right.
And this is quite important because you can do that on a location-specific basis. You don't do it for a given market or for the entire footprint. And this way you can not only reduce, delay CapEx expenditure, but it's also OpEx as well in terms of cost savings for the operator.
Your point is excellent. You know, when you think about what engineers have had to do up until now, they've had to understand these triggers as to when the network elements were reaching their thresholds, right? We're reaching these triggering thresholds. And they did that on an average basis. They did that on what their experience told them, and they did that on what the vendors suggested. But there is no average in the real world. In the real world, there is the behavior of the specific cell carrier, like you pointed out. And so one of the big changes that we're able to do now is we can bring the particular of the cell carrier and let you act on that information for that particular cell carrier. Every cell carrier you measure in your network, you'd have this information. And so your activity becomes much more granular. Instead of just blanketly adding a carrier for a given cluster of a given region, you would prioritize as to where you add your carrier, or you would change the way you add a new site if you're going to split sites based on the prioritization of where your customer experience was declining and where you wanted to again, meet it.
Yes. And now going back to real time, there is also there the need to predict the problem in addition to solve it. So if there is a problem that arises, obviously you have to deal with it, but even better, if you could predict, you can see the problem arising. Can you help operators do that?
Well, you made a good point. You know, people are talking a lot about, especially in the SON use case, about real-time adjustments to the network. But if we're adjusting in real time, that means the problem just happened a few seconds ago, right? So you really need to know how to forecast. You really need to know what the trends are. And you need to be able to predict that, yes, before the problem hits, this is what you need to do to optimize or to add capacity. You're exactly right.
Yeah, and so operators need to be able to. How can you help operators understand that to see what the problem is about to
So
happen?
what we do is, because we're able to behave like the scheduler and the radio resource manager inside the OSS, we're able to tell you what network elements are not in enough abundance for you to meet your customer experience today. That is, if you're not meeting those targets. But if you are meeting your targets, from the same dynamic, we're able to say, but we see, given the traffic growth, and we see how the trend is going, that these are the elements that you're going to be missing at this date certain. So we give you the current ability, but then through the trending and the forecasting, we're able to tell you what elements you're going to need to add in the future to maintain that quality of experience. It's exactly right.
Right, and that is crucial to to move forward. Now, as you sort of as an additional level of complexity, you mentioned sound, but and the sound would be often deployed in net environments where you have different interfaces that can be used and the operators use. So, in that circumstances, how do you optimizing the RAN means optimizing how you distribute traffic across different interfaces. Can you help operators coping with that? Because that's increases the complexity dramatically.
It's a great question. So even today, right, operators own 2 to 3 different networks, usually 3 different networks, right? And our solution lets them balance traffic and carve spectrum between those 3 different radio access technologies today. Now you add the fourth radio access technology, let's call it Wi-Fi. As long as the Wi-Fi is curated or owned by the network, or at least as long as the Wi-Fi behavior is being able to be monitored by that network operator, then it's just like those other technologies. You'll be able to see what its capacity is. It's different from LTE. It's different from WCDMA. It's got its own characteristics. But you'd be able to see, by acting like the radio resource manager for the Wi-Fi node, you'd be able to see how its capacity is. So then you'd be able, we are able to give the operator the information about, here's how your LTE network's working. Here's how your WCDMA network's working. If you bring in your Wi-Fi network, we'll be able to tell you how that's working. And then with that, you're able to balance traffic based on customer experience between those various things. Certainly, with the technology that's coming today, offloading onto Wi-Fi, if it's your owned Wi-Fi node that you have visibility into, becomes a very important tool in dynamic capacity management. Absolutely.
Mm-hmm. Now, another aspect which also relates to QoE is the increasing use of latency sensitive services. So on one hand, you have voice where the traffic is not growing that much, but it's still very important. And then you have video, which is becoming more and more important as a percentage of overall traffic. Do these services create special challenges for optimizing the RAM?
Certainly they do. I mean, now that we're packetizing voice over LTE and you've got VoLTE, then that's not a big capacity hog, is it? But it is critical that you deliver the right latency to it to be able to give the quality of experience. So now you've got to be able, as an engineer, to say, okay, how is the latency for my VoLTE calls? I understand I've got plenty of capacity if I'm already giving good support on HD video on this cell carrier, that's fine. But that means I should be able to provide great VoLTE, but not necessarily, because VoLTE, although it takes a small amount of payload, takes very good latency KPIs. So you have to be able to say, yes, now that I'm in VoLTE, how is my latency? And am I meeting those latency targets? A typical target for VoLTE latency might be 100 milliseconds in the latency with those VoLTE packets, for example. And this solution allows customers to manage the latency KPIs just like it does to blocking, dropping, and throughput, instantaneous throughput KPIs. It's a good question.
Yeah, so basically when you look, for instance, at latency from this point of view, the latency that is acceptable or that does not impact QoE for certain applications is different from others. So a KPI that, I mean, just to measure the latency as a KPI on its own has relative value. What you need to know is the latency for different applications, correct? And same with other KPIs as well.
That's correct. So, for example, one of the great things about Volti, right, is your QCI variability. So I'm able to say, well, based on what your needs are, Mr. Customer, I can deliver this kind of service to you. And if it's for Volti, I'll deliver you a clear as bell voice call based on these kind of limits of latency. If it's high definition video, I want to deliver X amount of instantaneous throughput on the downlink. And if it's on QCI 1, 8, 9, 7, whatever my QCI ranking is, you have to be able now, as an engineer, to see the information based on those QCI streams. Super complicated, super hard to get right, and it's something that we've been able to do. So when you talk about KPIs, and you talk about customer experience KPIs, now you've taken it in LTE to a new level. Whereas you're talking about latency on the voice packets, you're talking about differentiated KPIs per QCI bearer. And that just adds tremendous complexity to what the engineers are trying to manage to.
Yeah, it's more complexity, but also it gives operators much more power in terms of optimizing the resources they have, so they can use them in a much more intelligent way. So would you say that monitoring the networks has become much more important now, or is it the same?
Well, we're biased, right? We're in the business of helping operators monitor their networks. I tell you, it's always been the same in the sense of it's primordial to every operator that they deliver good quality of experience to their subscribers, okay? And the only way they can do that is know what the interface is between the subscriber and the network. The only way you can do that is test and monitor carefully. It's become much more complicated. LTE has a flatter architecture, but what it does inside that radio access technology is super complicated compared to WCDMA, which was super complicated compared to GSM. So the complications are only increasing. The ability to monitor and measure and understand those well is only increasing, but the need's still there, just as dynamic as before. It's just become much harder.
Yeah, and I guess like from an operator point of view, you need to make sure you don't get overwhelmed with the massive amount of data that you have to analyze. So you need to pick and choose what's relevant and discard the rest.
Super good point. I mean, we're flooded with data. The last thing operator needs is a new data stream or a new screen flashing on his or her monitoring board, because it's all about context. I've got so much data now. I can look at it all. It's all about taking the context of what's important, pre-processing, analyzing those to root causes, and then delivering information that's already got the context to it to the engineer, instead of just delivering the information. Engineers used to be that hub, right, where the information just passed to them, and then they were the router, and they knew what that information bit meant, and they knew what to do about it. Now there's so much information coming to the engineer, they don't have time or capacity to be able to do that. The engineer wants to understand what the priority and the problem is and what has caused the problem. Then they'll go ahead and fix it.
Yeah. So looking at the future, what is that you're working on right now to address the growing the growing need for optimizing, for increasing capacity effectively, and what are the next challenges that you're tackling?
Well, I'll give you a good example. Just the other day, we read that Huawei has come out with a new capacity boost enhancer for TDD LTE, and where they're claiming, it increases the capacity of the uplink channel on TDD LTE by 50%. It's great stuff. We then have to act as the radio resource manager and model that and be able to take advantage of that, to be able to show to our customers, this is in fact how that new enhancement is affecting your customers. So whether it's a SON application, or whether it's better radio resource management by the vendors, or whether it's a new technology that comes into LTE Advanced that improves capacity, we have to always be at that cutting edge to understand how that's really affecting the radio resource management, understand it, and then give that information to our customers, so that even with these new enhancements, they know what the customer experience is. And if they know what the customer experience is on their network, they can manage to it. And if they can manage to it, they can stay ahead of the game.
Yeah. Well, sounds very, very exciting. I'm sure you will never get bored. There's a infinite amount of work here to continue working on. Well, David, thanks so much for sharing your insights with us today.
Thanks very much, Monica, for the time. We appreciate it.
So this conversation with David FitzGerald at Ascom was part of a report around optimization that I wrote a sense of in collaboration with RCA Wireless News, and it's available for download. I would like to thank you all for listening in, and have a read through the report.